Okay, so then we want to start. Okay, hello everybody. So hopefully everybody is awake. It's 10 o'clock at least in my time zone. So any other time zones are here available. So if you have any questions, if you have any recommendations or whatever, I will try to check the chat here. I'm not sure if everybody can write to the chat. So it would be nice if one of the participants just try it. And I will have an eye on this one and try to make sure that questions that are coming up, I will just try to give an answer as soon as possible. Okay, so let's start. Now the difficult thing, I have to share my screen. I will try to do it without any big accidents. Trying chat, perfect, the first one. So don't be shy, ask questions, say hello. So sharing screen, so let's see. I want to share my PowerPoint. Okay, so can everybody see my screen? Just yes or no would be perfect. Then I would start with my session. Okay, so what's going on? What we want to do today? So what I'm not doing, I'm not switching my PowerPoint to full screen, because then I'm losing control over the Zoom stuff. So this is why I'm just sharing this screen like this. I think we will have the possibility to share slides later. Otherwise, ping me by Twitter, LinkedIn, or whatever. So you will get the slides anyway in some way. So what we are talking today about is, I want to talk about DevSecOps and why true immutability is something that will help you, and what are the low-hanging fruits, and why all this will lead to something called kills rebuilds, so to performance improvements. So first of all, for everybody who haven't seen me at some conferences before, my name is Sven. I'm developer advocate for JFrog, and I'm living right now here in Germany. And yeah, you can reach me on nearly all social media. My preferred one is Twitter, because it's easy and working everywhere. Otherwise, if you want to see some outdoor videos with text stuff in, check out my YouTube channels. I have it in German as well as in English. So what do we want to do today? The agenda is looks a little bit bigger than it actually is. So I want to have the start point where everything is coming from, and then we want to talk a little bit about dependencies, what's behavior, and why this is so important. Because this will lead to a huge potential of optimization in terms of security, compliance, as well as performance for the CI/CD pipeline. So this is the way we want to go. And the first thing I want to have as an intro is, you know, that everybody's slowly shifting, or not everybody, but a lot of projects are shifting slowly to this microservice architecture, to this cloud native architecture. What does it mean in terms of architectural point of view, or for the CI/CD pipeline? But everything I'm saying is more or less the same for a monolith. It's just a little bit bigger and maybe a little bit slower in some kinds. In some kinds it's faster. So I don't want to say left or right is better. I just take this approach because this is an actual fancy one. So normally you have this approach that you're splitting up your application in tiny pieces, and then you have this architectural point of view. So you have the service-oriented architecture. Long time ago it was SOA, and then it was RCP and whatever. So we had this a few times in the history, and the main thing is that you are splitting up your big use cases in tiny one, and then you have this API-oriented communication. This is an architecture, so splitting up your software in some tinier pieces. And the new thing more or less is that in general, we are talking now about a distribution, about this container-based infrastructure. So virtualization, not the full virtualization, it's para-virtualization by Docker. And as you can see, you have these generic approaches of architectural, the way of thinking, the way of dividing stuff. And it's in a way that this is not so well supported by tools in terms of that they are reducing workload for you. It's more or less an architectural thing, design and all this stuff. But if you're going more and more to this infrastructure part, for example, this container-based infrastructure or the implementation itself, the tooling will be more and more strong for you. So you will get more help and the tools can reduce workload, can do boring tasks for you and so on. And one very interesting thing is that, I think long time ago, we start talking about DevOps. I think the first mentioned on Wikipedia is 2009 or so. But slowly they are talking more and more explicit about DevSecOps. So this has something to do, and this is one thing that can lead to performance improvements inside your production line, even if you're adding a new piece here. But why this is, I will explain. This is one of the main topics. But what we saw is that with the splitting up, we will have shorter life cycles of independent pieces. And there was a paradigm shift, more or less, because people start thinking more often about rewriting instead of maintaining this piece. So this piece is so small that it's easier to rewrite sometimes compared to refactoring. If you have a bigger project, well, then it's not so easy. If you have a monolith, this is a dominant part, this refactoring part, this maintenance part. But this is more or less what they want to achieve. They want to achieve that you have a bunch of different technologies. Every microservice can be written in some kind of technology with all pros and cons. I don't want to say that it's better or less good or whatever. I don't want to give their value or rating. Just say that this independent piece can be written in different technologies, and this means that you have a zoo of technologies, and you have to handle this one. So we are supporting more and more this polyglot environments, and polyglot environments leading to more complex build cycles quite often. For example, if you're talking about one single thing, so one tiny part. So we want to focus now on one microservice, on one part or one monolith or whatever, so one unit that should be developed. And we want to see how big is the potential for performance improvements, for increasing quality and security at this part. And why immutability is one of the key points here. Checking out this single point you want to implement, then you have, for example, this application, this microservice, this REST endpoint, this whatever, this independent piece of functionality that should be implemented in a language of your choice. And the next step would be that you let it run in the next layer, so in Linux, because after this, you want to wrap it in Docker, or this is more or less the same step. So wrapping in Docker means more or less that's some kind of Linux that's running in. I think the most people are using this approach instead of a full virtualization. Just if they really need it, they will do it. But mostly they're going over Docker. It means some kind of Linux. So you're thinking about let it run in Linux, then declare what's Docker environments or this technical piece around this one. And if this tiny piece is able to run in a single Docker instance, then you can distribute it inside your Kubernetes universe. What does it mean? It means that with every layer you're adding the possibility for vulnerabilities and compliance issues. And if you are looking at it like an onion, the heart is the application. And if there is some vulnerability or some compliance issue, then this will be more or less available over all layers. And just have in mind the sum of all vulnerabilities is the full possible composition of attack vectors you have against the system. So it makes sense to focus during the development time to minimize vulnerabilities. Everywhere are compliance issues as well, but this is a different topic. And if you're looking at every tiny layer here, I want to explain first where this term shift left is coming from. If you're rotating this picture 90 degrees, then the application would be left, and if you start left and going right, then this would be the earliest point. So shift left means that you try to push as fast as possible all topics to the left side. It means it's mostly used in terms of security, but it's for everything. So if you want to have a high quality, you should start as left as possible, so earliest as possible, because if you start with quality just in the last step, then it's most likely that you're not reaching the possible quality. The same as with performance. If you're just choosing the wrong algorithm, then it could be a very efficient technical implementation, but the wrong algorithm is just slower than a perfect implemented bad algorithm. It's the same with security. So if you start with security in the beginning, then it will be the best result you can get. And the same with performance, with optimization, so everything. So if you start from the beginning, then it will give you the biggest potential for every part you're looking at. So this term shift left is mostly used in the security area, but I think it's just right for everything. So if you're adding the next complexity or the next thing you want to integrate, it makes sense to start as early as possible. But coming now to this test stack again. If you're looking at this one, you will see that more or less every layer will lead to some kind of repository. For example, the application is written in Java, then you have maybe Maven as a repository management system to deal with dependencies. On Linux, you have maybe a Debian or Alpine or whatever, but you have some kind of repositories, you're adding dependencies, and then it's a composition of your operating system layer. The same with Docker, you have some base image, and then you're adding your configuration on top of this. Or if you're doing all this stuff inside the Kubernetes world, you have Helm charts to build the full composition of the system. What most likely people are forgetting is that the DevSecOps part or the DevOps part will have dependencies as well in terms of tooling. So for example, the compilers, whatever tools you are using to implement your process means that this tooling should be available over the whole lifetime. So why not thinking about this one like a generic repository? Why this is important? Important is this because it means to secure your business or the production, you should be reproducible over all steps. And immutability is the main thing to reach this one. So if you want to make sure that, for example, your JVM that you're using for this step is for Linux from vendor A and the build number, whatever, then you should have this JDK somewhere in a repository because it is some kind of dependency, even if it is a tooling. And you have to make sure that this binary will be always the same. So you're not changing it. You're not just switching to a different JDK with a different build number, because you want to make sure, if you want to have a post-mortem analysis of some cases or whatever, that you're using exactly the same binaries to analyze the situation, to work on this, to build on top, to roll back to the situation, and so on. So immutability is something that is going over all layers, all dependencies, so it means over the whole infrastructure. If you're reaching the full immutability of a snapshot over the system, you can switch between snapshots more easily or more secure. And then tooling and all this stuff will be part of this as well. So for this, you need repository managers and some kind of possibility to scan here, for example, or to make sure that you're not dealing with compromised binaries. This is one thing, but why I'm talking about dependencies and immutability, and why this is a point that could help to improve the CI/CD pipeline in terms of speed. For this, let's think about the low-hanging fruits in your whole development cycle, the whole production line. It means the low-hanging fruits for a few things are dependencies. And it starts by the point that if you are a developer, if you think of this picture I showed before, this application and the Linux and Docker and all this stuff, you as a developer, if you are focusing on this application layer, what you're doing, you have these use cases that you have to implement, and on the other side you have the pressure to deliver something, because time to market is not only important for the economic driven guys, it's important for you as well. Why? Time to market means you have some requirement. This requirement can be delivered in a short amount of time. And this will lead to not only new features in a short amount of time, it will lead to changes in a short amount of time. It will be, for example, killed bug or vulnerability that's removed or whatever in a short amount of time is active in production. So time to market is not only in terms of money important, time to market is for us as a developer important to have a fast release cycle, to have the possibility to react on needs somewhere. It means bugs, vulnerabilities, compliance issues, new features, and so on. And time to market will lead you immediately to the question, make or buy. Make or buy. Buy is, in our terms, not only paying money for something, buy could be adding a dependency. So the decision, should you do it by yourself, or are you using something that is already existing? And this means that you are not reinventing the wheel, and this over all layers. So this is a question that a developer will have immediately. You're starting with the first line of code, and immediately you're thinking, okay, I have to create this PDF. What are the dependencies I can add to have the functionality to create a PDF? And then on top, you're creating your use case. So dependency are the most dominant parts in the whole view we have here. And if you're splitting this application, Linux, Docker, and so on, then you have mostly the behavior that during the time you're coding the application, the make or buy decision is, I don't know, you're coding, it depends what report you're reading from what institute or whatever. So this is why I don't want to write numbers here, but we are talking something between 40% up to 60% or 70% are dependencies, and the rest is something you're writing by yourself. So the amount of dealing with the dependencies is the most dominant one in terms of everything. So speed, how to speed up your use case implementation and so on. So dealing with dependencies is one very dominant thing, and this will lead to the optimization goal that you should have a focus on dependency and the way you are dealing with dependencies in terms of, are you grabbing them every time from the internet, how often you're doing it, and so on. So binaries and the management of these binaries, and this will lead more or less to the point immutability. So if a binary is not changing, it's immutable, and then you can replace it many times or can hold it because you don't have to fetch it again. This is one thing. But if you're looking at this make or buy decision, mostly during the application phase, you have the biggest make and the smaller buy. But even then, the buy is, or the dependency is the most dominant one. And if you're going to all other layers, more and more you have mostly the point that you're just configuring, and the rest is the dependency. So this is one thing. So dependencies are the biggest piece in the whole application, and that means you should focus here to speed up or to optimize. You have different things you could reach. For example, one risk is that you have issues in your compliance. So it means it's the wrong license at the wrong place or whatever. So it means this is mostly a one-time effort. So the lawyer will decide license ABC is good and it's not poison for our business. So then you can say, okay, these are the amount of license we are using and the machine will check it. This is one time, and then the most part is covered here, but the vulnerabilities are, for example, it's a recurrent effort. It's must be done on an hourly base, daily base, weekly base, whatever, because this is something that is constantly in a flow and it will influence all dependencies. And this means the most parts in your application. And if this is something the machine can check for known vulnerabilities, but the human has to decide what should be done at this point. So the thing is, the compliance are just in every layer. You have single independent pieces where you have compliance conflicts, and then you have to replace something. Replace means you have to find an equivalent dependency mostly, because this is just part in the dependency, and then you have to scan the whole thing again, but then you're fine. And the composition of compliance issues are not really a big deal because they are more or less atomic and independent. It means you can't combine different compliance issues to one bigger issue. Most likely you have this independent compliance issues. Different it is with vulnerabilities. Vulnerabilities are adding and giving you different paths to compromise your system. So you have different attack vectors against this one. So you have to make sure that in the whole dependency tree you must have the full impact graph. So you must, to understand the whole system, not only the single dependency in your application, it must be in the whole composite looked at. So this is a difference with vulnerabilities. Having in mind that dependencies are the most dominant part, and this management of this part is something that is slowing down in every single build cycle. Then you have to think about how to optimize this one, because if the compile process is the shortest one, and grabbing dependencies is a dominant one, scanning the dependencies is a dominant one, and then all this testing stuff, the TDD phase, so ramping up a test, let it run, and so on. What can we do here? Because we are talking about a polyglot environment with a huge amount of dependencies, with a huge tech stack, everything should be immutable, and how to ramp up this one in a way that it's fast. And dependencies and immutability is something that can dramatically change this one. Just as a side note about vulnerabilities, what is a part you could speed up here? For example, if you have this point that something is found, you have some kind until this information is public available. This is something you can just buy, wait, or whatever. You don't have something that you can speed up. But until the information is public available, it's up to you to have this information consumable inside your CICD pipeline. And then mostly the time between it is consumable, this information is here. You know that you have to change something in your dependencies or in your system in general up to it is available in production. This is mostly the longest time. And here you have the most impact because this is completely driven by you. So the CI/CD pipeline with the whole stack and redeployment must be fast. Otherwise, you are not able to fix in production not only bugs, vulnerabilities and compliance issues as well. So having in mind that bugs, you're working on this, it's completely your code, you're not changing the infrastructure, it's just a regular run. If you have to work against a vulnerability, single one, you are just changing a dependency version. The whole run is something. The really tricky part is a dependency changed the license and you have to find an equivalent of this implementation to make sure that this is running again. This is mostly, it's not so often, but if it has happened, then it's mostly a lot of work. Okay. Why we're talking about all this in terms of speed? So vulnerabilities, compliance, and bugs, it's more or less the same. So the safety belt is and will be a good test coverage. So this is a safety belt. Why? Because every change you're doing must be covered by test coverage. The test coverage is quite often a very time-consuming part. Thinking about web applications, you have a complex life cycle. You're ramping up the database, you're ramping up your service, you're ramping up the servlet container, you start Selenium nodes, you're connecting through this application, your test is running, it's time consuming, then you decommission all the infrastructure. So to have a fast reaction on the market, you must have a good test coverage. Good test coverage means you have a lot of tests, and if you have a complex architecture with a bunch of different technologies, this is a complex CI pipeline, means the provision of this one will be time consuming, it will be resource intensive, and so on. And this is just money and time you're burning at this point. And having in mind the dependencies, one of the biggest parts of binaries you're shifting around or that you have to deal with, you should have an eye on to make this part as lean as possible, so that really just a running test is a consuming time. Then you can scale horizontally and so on and so on. But the management of dependencies and changing is here most likely if you have something that must be done fast. So it means the dependency management has the highest impact. So dependencies in terms of the dependency between technologies, the dependency to different binaries to ramp up the whole stack, to ramp up the whole ecosystem. And every dependency is more or less based on a repository, but a repository is just, if you're thinking about repositories where you're grabbing all this stuff, you have to compose all this stuff, and you have to store your own results there, then a repository is just, you have a binary and you have some kind of version and some attributes around this. And then you want to have it in a way that other people can consume it, other steps can consume it. So it's more likely optimized for a machine. So you're dropping a binary, it will be marked with some attributes, with a version and so on. And then it can be consumed in the next step or during the next phase, or must be available until it will be used to recreate a state that was existing a day or months ago. But if you're looking at different repositories, they have different behaviors. So there, for example, Git, you have a repository with a branch, you have a path file name and a commit tag. This is how to address a binary inside this Git repository. If you're looking at a dependent repository, you have most likely just a repo where you're going through, and then the architecture, it's for this hardware architecture, and then a package name and a version. So it's not fitting really together, but both repositories. If you're looking at Maven, you have this repository somewhere, and there's this group ID, artifact ID, version ID. This is good because here you can merge repositories very easily. If you're looking at Debian repositories, it's not easy to merge repositories because they have this package.gz file, and this is a directory for the content of repositories. So if you want to merge repositories, then you have to deal with this new package.gz file. It must be a virtual one that is aggregating stuff and so on. So it's not so easy. Docker, for example, is quite easy. It's just a repository name and a tag or hash or whatever. And then you can easily merge if you have no naming conflicts. So you have all this stuff managed in repositories, but they have different behavior in terms of addressing and the possibilities to aggregate repositories. So to think in a way that you can put a generic strategy on top of it. One basic thing that is really a beast, if you're talking about dependencies and to analyze this stuff and handling this stuff is, for example, Git has no dependency in terms of, well, whatever you want to say. You have forks or clones and that's it. If you have Docker, then you have a linear list. You have just one from statement, and this will have just one from statement again. So you have a linear list of dependencies. This is a quite easy thing to handle. But if you're talking about Maven or other dependency management system, it is a graph. Hopefully it's a tree. But if you are in a bad luck, then you're building graphs with cycles. And this is based on some stuff. So you can declare versions like a version range, and this will include some versions maybe from the future, and then you can build cycles and so on and so on. So it's loosely coupled, you have transitive dependencies and so on. So this is something that can lead to challenges if you have it in a long running system. But in the end, whatever you're taking from these repositories, there's only one thing that will help you to speed up. This is security based on fingerprints or the management based on fingerprints. So if you have a binary, and this binary, you can create a fingerprint, you can deal with fingerprints. It's a dramatically reduced amount of data, and this can be checked independently and concurrently of all binaries. So there is a speed up. But there is one thing, the fingerprints mostly built on top of the PGP keys or PG keys or whatever. And this means you must have global access to this fingerprint database somehow, or to this key database, and you're trusting to this one. So having in mind that maybe it would be interesting to have a cache from this one in your own organization to speed up this request times to verify binaries and make sure. I have a YouTube video on this one. It's an old topic, but still useful. But the main thing is that is really pain in terms of performance if you're dealing with later steps, is that more and more people start building fat jars. And why they are doing it? They are doing it in a way that they have just one jar that they can shift somewhere and can ramp it up, can start it. On the other side, you're losing a few things. For example, if you have this dependency tree and you have transitive dependencies, and you're creating a library or a module that's used by your colleagues, and you want to use your version of Google Guava, and you know, between Google Guava versions, you have sometimes this conflicts, then it's a common practice now that you're saying, okay, I'm taking this Google Guava version and I'm repackaging this stuff and pushing it to my jar. So, and what you're losing with this? What you're losing is this repackaging means you're changing inside the binaries, the import statements, and all this stuff. So it means you're creating new binaries. Every class is a new binary, and this leads to new fingerprints. So everything that's based on fingerprints will be in trouble because caching and all this stuff is just not possible because you're creating new binaries. And then the other worst thing is, if you're adding your transitive dependency or your dependency with repackaging, and then later you find out that this package will have a vulnerability, for example, then how to find it, how to build it. So you have to recreate your binary, you have to repackage this stuff, you're pushing everything back to the production line. Everything must be one by one built again, and it couldn't be done concurrently. If you're not using this repackaging and you have a transitive dependency, what you could do, you can just override the transitive dependency in your composite testing with your test coverage is everything is fine and that's it. And then you're getting rid of vulnerabilities, bugs, or whatever. So this is an improvement, and fat jars are some kind of working against it. But dealing with dependencies means that you want to have the best result on the dependency definition itself, if you're declaring this one, and then you can see, okay, what is going on now with this stuff, what binary I'm using, and you can do a lot of stuff concurrently if you're dealing some workflows on fingerprints and all this stuff. And you can change transitive dependencies, so you don't have to build the whole chain one after another. You can just change your dependency and you don't have to wait until the whole pipeline is recreated. This will speed up. But that means that you need this information as soon as possible, and this is a good way. If you have this information for the dependencies right now in your IDE, it means shift left in this term. How this could look like, I showed you with the JFrog IDE plugin. You can have it with a free tier Then you can just add your dependency, and then you see all this stuff, how this is done. There's a YouTube video. And I have an example how to harden a complex stack that's going over two technologies, NPM as well as Java with Vardin stack. And I'll show you there how this improvement is done easily. But talking about these repositories and all this stuff means we have to manage now, because otherwise we are not able to improve. What we can improve to get rid of rebuilds is that we are working with the possibility to change transitive dependencies, because then I don't have to rebuild all this stuff. I can just use this existing binary that is consuming in the original version the older dependency, but I'm using this binary with a new version, so I'm not building this stuff again. I'm just switching to the new dependency, and then I don't have to rebuild my dependency. I just rebuilding myself. This is reducing the rebuilds, but there is a way more powerful way if you're looking at the repositories. So what we have in common over all repository types is that we have local, remote, and virtual repositories. What does it mean? Mostly people are using repositories inside their CI/CD pipeline in a way that they have it locally on the machine. It could be a developer machine, it could be the node that is building your stuff. It has a local repository, for example, this Maven, this M.2 folder, and then you're grabbing from a remote instance everything. You want to have a clean build. What you're doing, you're throwing away your Docker image, creating everything from scratch, and then how to deal with this repository, it's grabbing this stuff again. So if this is a remote one, you have the latency. So this is, well, most likely this local one is just caching for one cycle. It will be different if you're building a hierarchy of these caches, more or less, or these repositories, so you can speed up. So the remote one that is out of your company is mirrored inside. So you're just caching here. It's fine. It's an old approach. Everybody knows it. And then you have to deal with a hierarchy of repositories. So how to promote stuff. So you are creating a library that should be used in a different part of the company, but you have this hierarchy. What is the right place to push stuff? For example, you're pushing now to your father, and then the other part of the company is taking this father as a remote one and grabbing this one down. So you have at least this round trip over the hierarchy inside your organization or inside your build steps or pipelines or whatever. So this is, it's better than grabbing everything from outside, but it's not optimal because you have this timeouts, you have this delays, this caching delays, and so on. And it's not easy because you have to decide for every build step what is the right target to push through. So the configuration will be more complex. So how to do this one? And the other thing is you're creating a lot of stuff, how to maintain it so that your disk space is not just filled up with useless binaries you're never using again. So I saw an approach I personally don't like is that people start sharing version commit hashes and then say, to get rid of this maintenance and complex hierarchy of repositories, we are just building everything from scratch. This is a possible solution, but I personally don't prefer it because you're just burning CPU cycles because you're doing everything again and again and again and again. So this doesn't make sense. What's better? Better is if you're working with virtual repositories, if you have the choice. So then you can have this single virtual repository for a build pipeline, and you're aggregating for every build step just the repositories you need. And this is good if this virtual repository is able to handle push as well. So you're not pushing to a dedicated repository, but you're pushing to the virtual repository you're using for your dedicated build pipeline that is created. Because in Artifactory, for example, virtual repositories are just lightweight thing. You can build them quite fast and easily. So you're just pushing to this virtual one, and there is the right remote one that you're pushing through. And then every build step can have a new composition, a new view via virtual repository. But what makes the performance here? If you're looking at the frequency binaries are created, it's most likely if you have this feature branch, you're creating a binary, it will grab all dependencies, it will create something, and then it will be just available until the first merge is undeveloped. Then it could get rid of all snapshots that are created from this feature branch. You can just delete it. With a virtual repository, you can say at least for every feature branch, you have a virtual repository. You're working in this virtual repository, and every feature branch has a corresponding local repository where the binaries from the feature branch are stored, that are created. They are stored here. Then immediately you can say, okay, this one is a merge is done on develop. I'm killing this repository from the feature branch, and everything that is created during the time of this feature branch will be deleted. You're not able to handle it, or you don't need to handle it. So you're building it anyway with development. And then with development, you're doing it with staging and production and so on. But this is not really improvements in terms of speeding up the pipeline. The real power of virtual repositories in dealing with dependencies, and dependencies are, for example, at least between build steps. And this is a big thing, because if we are dealing with dependencies, what we could do, we can build a composite of external repositories where all the external stuff is. They are immutable, so I can store them indefinitely. I can store them as long as I want to have. And then for every build, not only build pipeline, for every single build, I'm creating a virtual repository. They are the composites of the external ones and a local one for my dedicated build step. And then during my build steps, the first one, I'm creating the jar I want to use in my web service test or whatever. I'm creating this jar. Then I'm pushing it to the local repository that is for this build step, not build, so this build step. The virtual repository is for the next step, aggregating all remotes we have, plus the local repository from the previous build step. And again, you're using the same configuration, you're grabbing from the same virtual repository. It's now including the binaries from the previous build step. You're pushing the default for this one will be the local repository from the next build step. So build step 1 has a local repository, local 1. Step 2, local 2. Step 3, local 3, and so on. And with every build step that is done, you're adding this local repository to the virtual repository. And this means if you have a long-running CI pipeline, because tests are taking a long time, ramping up stuff, and so on, it would be bad if you have this web test, for example, building binaries, grabbing the NPM stack, doing all this stuff, generating stuff, and then one unit test is failing in a later step, step 5 or 6. It would be bad if you're throwing everything away and building all this stuff again just to verify this test is running. It would be good if you can hold all build steps that are done already, because you're not changing something. They are immutable. Everything that's created from the previous build steps are immutable, and just start from scratch from the latest failing build step inside your build pipeline. So, and this will speed up dramatically the way you're creating stuff, because every binary you're creating is immutable per definition, even if it is just from a build step. Dependencies are cached really, really excessively, so that everything is just fetched once. If you rerun your pipeline because you have failed builds, you're just redoing the failed build steps. So build a fine-grained build pipeline with fine-grained steps, and then you can just rerun the latest steps. So you're killing rebuilds because every previous steps are not done again, and you're speeding up because you're just working on the thing that failed, and then you can improve. So this one is really something that you can do if you have this concept. So with Artifactory and X-Ray and pipelines, this is very smoothly implemented, but you can do it with Jenkins, TeamCity as well. But make sure that you have a very lightweight repository manager like Artifactory, where you can build local, remote, and virtual repositories. Virtual repositories with the possibility to push through a virtual repository that's redirecting to a local one, and grabbing this over all dependencies. This step you can do with Maven, with NPM, with Debian, with Docker, with everything. And with this, you're minimizing the rebuilds really dramatically, and this will use less CPU time, less bandwidth, and so on and so on. So this is the first step. If you want to know more, sometimes I'm talking about different things, you can register to my mailing list. Otherwise, I would say here it's time for questions. And I would stop sharing my screen. So, okay. Any questions so far? No, it's early morning now. Okay, so if there are no questions anymore, yeah, well, think about the possibility of what you can do with repositories to speed up your pipeline. Have in mind that immutability means not only external dependencies, every build step can be immutable, the binary, so that you are not redoing this stuff. The composite of repositories will help you to speed up this one. And at the same time, you have an easy way to check all binaries and compliance issues, because you have to do it only once, because you're reusing the binary again and again. So, well, that's it from my side. Feel free to ping me on Twitter or on chat or whatever. So if you have any questions, recommendations, yeah. Otherwise, thank you very much for attending. And I would give back to the organizers.